In this video, we're going to take a look at our main blueprint and the logic for the fists. First of all, I'm using simple integers instead of booleans for the drive logic. I find it much easier to check if the variable is equal to 0 or equal to 1 rather than checking if it's checked or not checked. There are also some advantages of using an integer. First of all, its value can be extended. We can also use a switch on integer and based on the value we can have switch to multiple logics. We can also nullify floats and other integers when our variable is equal to 0 by multiplying. With this said, let's take a look at the logic of the fists. First of all, we have two custom events, fists punch left and fists punch right. We're checking first whether fist will punch right is more or equal to 1. It's important that it's not 0. Same for the fists punch right. The following logics are symmetrical. First, we're setting weapon will fire to 0. This prevents other things from happening and interrupting our logic for the punch. Every other fire logic or weapon switching first checks if weapon will fire equals to 1 before executing the logic. So once we have set this to 0, nothing else will happen. We cannot use this one for our fists, however, because we need them separate. And for this we have this additional variable dedicated to each fist. Let's take a look at the variables for the fists. There are only 3 of them. Fist damage float, fist will punch left, and fist will punch right. So we're setting weapon will fire to 0. We are setting fist will punch left to 0, and here for the right, of course, we're setting weapon will punch right to 0. And after the delay that represents the punch rate, here for the right fist and here for the left fist. And after the delay, that also matches the length of the animation for the punch, roughly. We set weapon will fire back to 1 and fist will punch back to 1 as well. Same here. We are playing corresponding animations for the left and the right fist and spawning the sounds. Then the logic is the same. Simple line trace by channel. There are 2 channels available by default, visibility and camera. I'm using visibility. Most of objects by default blocks visibility channel, so we can get a hit result. We will take a closer look at using different trace channels later on. We need the start and the end of our trace. It begins at the world location of our first person camera. Then we get a forward vector. We multiply it by 150. And this is the length of our vector, of our trace. So anything further than 150 units from us will not be hit. Next we have a branch. We need to check if we hit something or not. If we don't hit anything and try to apply some logic further, we will get an error in the output log. So when our line trace return a value to us, the condition is satisfied, and we apply damage. This is a standard node. The base damage we connect to our fist damage variable. It is a float, and the default value is 10. The damage has to be applied to the actor, and here we can see break hit results from the out hit of our line trace by channel node. This gives us the information on what we hit. For the apply damage node, we need the information from hit actor. This is the actor that will be damaged. Next, we're checking if the component of our target is simulating physics. In case it does, we apply impulse at location. We need a vector for it. So I take normal from our hit. However, the normal is facing to us. So I'm multiplying it by a negative value. We also multiply this by fist impulse multiplier. This multiplier is used by the berserk logic. In both cases, whether our target is simulating physics or not, we're going to fists hit fx. This is a custom event. Here it is. You can simply double click on it and we will be transferred to the custom event. You can see a number of inputs and outputs. These are custom inputs and outputs. Let's see how this can be set up. We add a custom event. We will call it demo event. And here we can see a number of inputs. New parameter. Let's say we need a name. And we call it bone name, so that we understand what type of name we are transferring. We hit compile. After that, we want to call this event. For example, here, right click and type demo, and we get demo event. And here we have the input for the bone name. This way we can transfer some information from one part of our graph to another, so that we don't have to drag, for example, the name of our bone across the entire screen. And also the event might be triggered by different logics and get different input for the value. So here I am collecting the information from our break hit results and transferring it further for the logic of the hit fx for the fists. Now I will delete the demo events. And first we're checking the surface type. Switch on E physical surface. We need it to return flash value for the logic to continue to spawn our blood splatters. We only have default and flash. However, this can be expanded. Let's see how this is done. In the project settings, if we type physics, we get the physical surface list. And here, surface type 1, we see flash. If we go to our root folder, we will find physical materials, and here we can see flash physical material. Whenever we create a physical material, like so, we can assign surface type. We have default flash. And then this physical material, we don't need this anymore. And then this physical material can be applied to characters. It can be applied to the materials itself, or let's take a look at the fire demon, or to capsule component. There is physical material override. So once this set to flash, whenever we do the line trace and hit something that has that physical material, it will return the information to us about the physical material. We collect it here, pass it on here, And here we check the surface type. When it is flesh, then we go to our blood splatters effects. Now let's take a look at the particle system that we use. You can simply click on this icon browse to get there. I will also show where it is in the folders. Weapons, hit effects, blood splatters. We have a particle system and two materials. Let's first close the fire demon here so that it's not in the way, and the project settings. So we will open the material for the splatter. We will open the particle system and the material splatter decal. First, let's take a look at the particle system. You can see the splatters. The distribution can be adjusted in initial velocity. If you add minus 400 here, and minus 400 here, we will see that it goes into in all directions. Setting it back to 0. You can play with these values. This emitter, we can, in the required, uses the material called M-splatter, this one. In this material, the color is set to particle color so that it can be defined by the particle system. And the opacity is taken from the particle sub-UV. This image, getting back to our particle system, here we scroll down and find the sub-UV panel. We can see that sub-images horizontal and sub-images vertical set to 4 by 4. And the interpolation method is set to random. So at random, it will divide our image 4 by 4 and pick a random frame from it. 4 by 4. Next, let's go back to the logic. So we spawn this emitter. And then we bind an event on particle collide. And here we create dynamic material instance called M-splatter decal. Let's take a look at this material. The color, the base color, and for the opacity we have texture object with sub-UV function. Divided 4 by 4, and the frame parameter represents the frame that is being rendered. We can set the preview to this plain primitive, get a live preview. Okay, there it is. So this parameter controls which of these frames is being rendered. So in case you have, for example, 5 by 5, you simply change this to 5 by 5. And this frame will have the control of which of those 25 possible frames is being rendered. Now it is 4 by 4, so we have 16. So we can change the default value, for example, to, I don't know, to 5, and the image changes. 10, and we have another image. Let's set it back to 0. So back to our main logic. We create this dynamic material instance. we get the return value for the target to set a scalar parameter value. It is this parameter that we will be setting. Back to the main logic. Here we specify the name of the scalar parameter. See, it's frame. So to demonstrate this whole logic, whenever we throw our left or right punch, we spawn the particle system. The particles collide with the surface of the floor and spawn the decals.